solving differential equations in terms of y. So here we're going to take a look at solving differential equations that are in the form dy dx equals some function of y. And let's just jump straight into an example. So let's have a look at, if we have dy dx just equals y. Now you might think we could just go ahead and integrate both sides here, but we'd have a bit of a problem because, remember, one way to think about it is if we multiply both sides of this equation by dx, we'd have dy equals y dx. And then integrating both sides here we'd end up with an integral of y with respect to x, which wouldn't really get us anywhere. So we need to just do something before we go ahead and solve this equation. So let's just write it out again. Dy dx equals y. And what we actually want to do here is just flip both sides of the equation first. So we'd have dx over dy equals 1 over y. And now, if we were to multiply both sides by dy, we'd have dx equals 1 over y dy. And we can go ahead now and integrate both sides of the equation. So integrating 1 dx is just going to give us x. And integrating 1 over y with respect to y is just going to give us ln of the absolute value of y plus a constant. And now we need to make y the subject. So we'll minus c from both sides. So we'll end up with the natural log of the absolute value of y equals x minus c. Let's take both sides of the equation and make them the power with a base e. So we have e to the ln of the absolute value of y equals e to the x minus c. Then e to the ln of the absolute value of y will just leave us with the absolute value of y equaling e to the x minus c. The absolute value of y, by definition, tells us that we should be looking at the two cases of plus and minus y equaling, now let's rewrite e to the x minus c as e to the x times e to the minus c. Let's take our plus or minus to the other side. So we get y equals plus or minus, we'll write e to the minus c first times e to the x. And we can just because e to the minus c is just a constant, so we can let plus or minus e to the minus c equal a. And this will give us y equals a times e to the x as our solution to the differential equation for some constant a. Let's look at another example. So we have, in an electric circuit, we've got a capacitor of capacitance C charged to a potential difference E and is discharged through a resistance of R. And we have Q being the charge on the capacitor at a time t. And all of this is described with the differential equation of dq dt equals minus q over rc. So we're obviously here r and c are constants. And we also know that initially, so when t equals 0, that q is equal to E times c, where E and c are constants. And we need to find an expression for q in terms of time. So our variables are obviously q and t, we can tell from our derivative here. And taking the dt to the other side here, we can't do because we have a q over here. So this is a situation where we do need to flip both sides of the equation, first of all. So this will give us dt over dq equals minus rc over q. And now we can go ahead and integrate both sides of the equation. Or you can think about timesing by dq if you like, both sides first. So they cancel out. And we have dt equaling minus rc over q dq. And we can integrate both sides now. So the integral of dt is just t. And we could take the minus rc outside of the integral because it's just a constant, which would just leave us with the integral of 1 over q dq. So this is going to give us t equals minus rc. Now the integral of 1 over q is just ln of the absolute value of q plus a constant. And we need to go ahead and make q the subject. Or let's find our constant term first. So we know when t is 0, q is equal to EC. So we have t being 0 minus RC times the log of the absolute value of EC plus a constant. So let's add the RC, ln, EC to both sides. So we just get C equals RC times the ln of the absolute value of EC as our constant. So let's go and sub that back in. So we get T equals minus RC times ln of the absolute value of Q plus RC times ln absolute value of EC. Now we need to make Q the subject. So let's factorize out the RC and just change up the order. So I'll write ln of the absolute value of EC minus the ln of the absolute value of Q. Let's divide both sides by RC. So we'll have T over RC equals, now we have a subtraction of two log terms, which will end up being the division of these terms. So it'll be ln, the absolute value of EC over Q. Let's take both sides and make them the powers with a base e. So we'll have e to the power of t over rc equals e to the power of ln, absolute value of EC over Q. This will give us just the absolute value of EC over Q equals e to the power of t over rc. By definition, absolute value, we should look at two cases, plus and minus case. So we get the absolute value. So we get the plus or minus EC over Q equaling e to the power of t over rc. Let's take the plus or minus to the other side. So we get EC over Q equals plus or minus e to the power of t over rc. Let's take the reciprocal of both sides of the equation. So we get Q over EC equals plus or minus 1 over e to the t over rc times both sides by EC. So we get Q equals EC. So we get Q equals plus or minus EC. And we can rewrite this E with a negative power. So it would be plus or minus EC, e to the minus t over RC as our final solution to that differential equation.